So we are starting a new section calling adding vectors with magnitude and direction. I've done one problem here. I'll kind of work my way through it. I have more problems, but I'll do it from beginning to end. But we have a vector right here, vector W, that has a magnitude of 3 and an angle of, say, 70. So I put 3 cosine 70 and 3 sine 70 as my components. And then I have the other vector, which is a magnitude of 7, and its angle, it goes 310 degrees. So I took those components, and when I added them together using the graphing calculator, I got a 5.53 and a negative 2.54, which clearly puts me in what's called the fourth quadrant. Now, in order to find the measure of this angle, you always take the y value over the x value. And when I did that, I got this negative 24.7, which represents this angle right in here. If I go from my initial side and I go down, that's actually like saying negative 24.7 degrees. If you go from the initial and you go what's called clockwise, it's actually going negative. All right. My final answer was 335.3 because all the way around, that's your 335.3, that section. And so that was my angle. Whenever you're trying to find the magnitude, all you have to do is take your x component, square it, take your y component, square it, and take the square root. When I did that, I ended up getting what's called the square root of 37, and that's approximately equal to 6.08, and so we rounded it to 6.1. Now, I'm going to be going over the next problem step by step all the way through, but I just wanted to make sure students who have already seen me do this were able to look at it later if they needed to. So I got the right answer, just so you know. We're going to go on to the next problem. So here we go. From beginning to end, here's how you do the work. So we've got a blue vector, vector v, okay? And so I'm going to write its components. It's got a magnitude of 8, and it looks like the angle goes from here all the way across, so it's 140 degrees. So the x component is going to be 8 cosine 140. And the calculator, it'll just be parentheses, and you put 140. Over here, we're going to put 8 sine 140. And there's the component for vector w. Right underneath it, I'm going to put that's vector v, not vector w. There we go. That's vector v. Now I'm going to write vector w. So vector w looks like the magnitude is 4. So to find the x component, I'm going to put cosine of 40. To find the y component, I'm going to put 4 sine 40. And what I'm going to do to find my final vector, which is going to be vector v plus vector w, is I'm simply going to add them together. But I'm going to use the graphing calculator to do that. So I'm going to clear all this out. Look at my components. 8 cosine 140, 4 cosine 40. 8 cosine 140 plus 4 cosine 40. So this is going to be my x component for vector v plus vector w, negative 3.06. So I'm going to use negative 3.06. And you're allowed to do your intermediate calculations to the nearest hundredth. So that's why I did negative 3.06. Now I'm going to do 8 sine 140 plus 4 sine 40 to get my y value of my component, which is 7.71. So I'm going to put 7.71. So this is the x value of the component, and this is the y value of the component. So if I wanted to find theta, okay, where would I be located if I'm at a negative x and a positive y? It's going to be located in quadrant number 2, where all the x's are negative and all the y's are positive. Okay? So all I'm going to do to find my angle, just remember, theta will always equal the inverse of tangent, and just simply put your y component over the x component every single time. So watch how I do this. I'm just going to hit second tangent. I'm going to get my y component, which is right here, divide it by my x component, which is right chair, press enter. And so we have what? Negative 68 degrees. Now, I want you to think about this. If we have 180 and you just simply add this negative 68, you get 111.66. So what I want you to understand, I'm going to put 111.7 degrees. All right, so what I'm going to do right here is this, right now, this clearly puts me in the second quadrant. So I'm going to use 111.7 as my theta. Now, if you wanted to, hey, if you wanted to, you don't have to keep the negative. You could just do y over x, and you don't have to worry about whether it's negative or positive, okay? So you could just, if you want to delete that little negative there and just get 68, as long as you guys understand this rule, okay? So we're going to go over the quadrant rule one more time. So if you don't have this in your journal, you might want to put it in your journal. So here's the quadrant rule. In quadrant number 1, where everything's positive, whatever theta is your answer. In quadrant number 2, where the x's are negative, the y's are positive, your angle will always be 180 degrees minus theta. If you're living in quadrant 3, where a lot of my students live, where the x's and the y's are negative, then you're going to take 180 and you're going to add theta to it for your final answer. And if you're in quadrant number 4, where the x's are positive, but all the y's are negative, you're going to take 360 and you're going to subtract theta for your final answer. So make sure you guys have that in your journal. It makes things a lot easier. It's either this, 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 or this. So that's why I did 180 minus the theta to get this 111.7. Okay. Now we're going to find the magnitude. So how do we find the magnitude? We're going to take the square root of my x component squared plus my y component squared. And that's going to give me my magnitude over here. So since I already have them, okay, I'm not going to, apparently my students let me know that it's apparently not okay to round your calculations to the nearest hundredth, because they're getting answers wrong even though they did all the right processes. So you know what? We're not going to round. So I am going to line this out and say, don't do this, because apparently this is not the truth. There, I said it. Okay, so let's go to our components. Open parentheses. Let's go up here and grab him. There's my x component right there. Close it, squared. Take my y component right there. Close it, squared. Enter. I'm going to take the square root of that baby. 8.3 is what I'm going to use. 8.3. So if you're wondering what I did, I took the whole enchilada of that negative 3.06 and I squared it. Then I took the whole enchilada of that 7.71 and squared it to get to that 8.3. So we'll see if that will suffice for this answer. 8.3 and 111.7. 8.3, 111.7. All right. 8.3, 111 point. Oh, that's 117. Hold on. 111.7. Hopefully I wrote that down right. Woohoo! All right, last one. All right, we have two vectors. Looks like I got a kind of a poopy color and blue. It's going to use orange. That looks poopy, doesn't it? I never understood when people, you ever seen this color on a vehicle and you're like, why would you pick the poopy color? I mean, sorry, whenever you have kids, you see this color come out of their diapers a lot, just so you know. Okay. So you have 7 cosine, hopefully it's not coming out of your teenager. Be bad. 7 cosine 50. Then put 7 sine 50. Okay, and then over here we've got 4 cosine, but I'm using that 310. Okay. All right, so there we go. So now we're going to add these babies together. I'm going to get my final component, and that component's going to help us get us our angle, and it's going to help us get us our magnitude. So here we go, 7 cosine 50, and so we're going to add these together. So let's make sure we add these together. 7 cosine 50, 4 cosine 310. Got it. Let's clear all this out. All right. 7 cosine 50, and I believe it was 4 cosine 310. You'll see me kind of go back and forth because I want to make sure did everything right. 7 cosine 50, 4 cosine 310. Got it. So now I'm just going to do 7 sine 50. Oh, 4 sine. Does everybody see like what I do every single time? I just put it all up there together so I can make sure I have my answers in my calculator all together. Man. So I have 7.07, so I'm going to use 7.07. Then I have 2.39, or sorry, 2.29, which is basically 2.3. So let's put 2.3. That's my x component. That's my y component. Now what I'm going to do is I'm going to find the measure of my. Now, by the way, which quadrant am I in right here? What would you guys say? No, it's not the 5th quadrant. The 1st quadrant. Okay. No, it's not the 7th quadrant. You can tell we're at the very end of the school year where everybody's going a little mad. I'm losing my marbles. What? So we're going to go second tangent, going up, getting my y component, dividing it by my x component, because that's what I do every single time. And I get 18. And since it's rounding it to the nearest tenth, that's just 18. So I'm just going to put in 18. What am I going to do for my magnitude? I'm going to take my x component and I'm going to square it. Then I'm going to take my y component and I'm going to square it. And then take square root of it. So open parentheses. Take my x component, square it. Take my y component right there. Square it. Press enter. Then I'm taking the square root of that guy. And I get 7.4. So all of that's approximately equal to 7.4. So I'm going to round my answer to the nearest tenth, but I'm going to line out. It's not okay to round things to the nearest hundredth because some of my students are doing that and they're not getting the right answer. So I'm just doing it at the very, very end. 7.4 and 18. Hold on, 7.4 and 18. Nailed it. Let me go back real quick to a super important chart. Where's my super important chart? There. Oh, there it is. Right here. This is the chart that I want you to understand. This is what you need in your journal. If you're in quadrant 1, the answer is just theta. If you're in quadrant 2, whatever you get, take it away from 180. Quadrant 3, add 180. Quadrant 4, take it away from 360. That's your answer. Have a wonderful day. Uh-oh. Is it not recording anymore? Recorder is recording. How do I stop the recorder? There is, it's saying it's recording. Click here to